Good morning, good afternoon, good evening, everyone. Firstly, thank you very much for joining us in this webinar of ours where we're going to talk about threat intelligence. And I'm going to be your host. I'm Sonali through the whole webinar. And throughout the webinar, if you come across any technical or non-technical glitch or error or issue, just do not hesitate, let me know. And for doing that, you can easily put your query in the chat window. And if it doesn't work for you, then you can also alert me via raise of hand, and I'll be there to get it sorted for you. Another important thing to remember while we go through this flow of webinar is that there is a Q&A session that we have parked about 15 minutes at the end of the webinar. But to make this discussion more engaging and more exciting, I would recommend and suggest each one of y'all to kind of share your questions or queries or suggestions as we progress through the slides and through the course of the whole webinar. Now, what will happen because of this is we'll get more time to address the queries, more time for discussion. Plus, the additional 15, 20 minutes at the end of the webinar will give us that additional time to talk to speakers and get their inputs and perspectives. Thirdly, the most important thing to remember is that we are recording this webinar and we'll be sharing a link with you post the webinar is done. So if you missed some part, if the audio was not good during a particular period, do not hesitate, do not fret. The whole recording, the video recording will be shared with you after the webinar. But I guess, yeah, this is how it is. And as you all know, I have my colleagues and experts, Igor and Kirill Puzenko, who will be talking about threat intelligence, which is a very important topic, which has been discussed and deliberated in the telecom circuits of lately, so much more because of the latest GSMA MoTIF framework that was announced. So with the light of all this, what we are going to do today is talk about what is threat intelligence. More so, the conceptual aspect of it, the concepts of threat intelligence within telecoms. What comprises threat intelligence? How do we really use it? We're also going to touch upon MITRE FiGHT and GSMA MoTIF, the framework that everybody is aware about. But what really lies within them? What can be used and how it can be used? Thirdly, the most important track that we are going to also cover is how do you really use threat intelligence in the telco context and use it to create proactive telecom defense strategies. So these are the tracks that we are going to cover. And with this, I will pass on and invite and welcome our speaker, Igor, to take you through the whole session. Igor, over to you.
Thank you, Sonali. Hi, everyone. Thank you for joining us. The topic of today's webinar is key role of threat intelligence in proactive telecommunication protection. So Kirill and I will talk about what threat intelligence is about in context of telecom security. We also consider threat intelligence frameworks user gauge and also analyze some examples of already well-known attacks using this framework. So a couple of words about who we are. So I'm Igor Pigolitsyn, 5 years in telecom security. I'm working at SecurityGen in a position of telecom security researcher, responsible for 5G security research in our company and also conducting telecom security assessments in 4G and 5G network for mobile operators for many years. And Kirill, please, over to you.
Hi, everyone. Thanks, Igor. My name is Kirill Puzankov, and I'm 10 years in telco security, currently product manager in SecurityGen. So we've been exploring telco threats and vulnerabilities starting from SS7 till 5G for several years. And currently we're growing solution for protection of mobile core networks and also for the ones that provide visibility of the network security posture and conducting actually identification of the threats. Thanks. Go on, Igor.
Okay. So, but first of all, let's define what is threat intelligence is about. So actually, threat analysis, also known as cyber threat analysis, is information gathered from several sources about current or potential attacks on organization. The information is analyzed, refined, and systemized, and then used to minimize and mitigate cybersecurity risks. So the main purpose of this analysis is to show organizations the various risks they face as a result of external threats, such as zero-day threats and complex persistent threats. Also, TI analysis includes detailed information and context about specific threats. With this information, organization can make informed decision about how to protect themselves from the most, let's say, common attacks. What is the lifestyle of threat analysis? The process of collecting threat intelligence includes various stages, like following. The first one is goal and objective. In order to select the right threat analysis sources and tools, organization must decide what it hopes to achieve by adding threats information to its security solution and strategy. Then we should collect some data, such as logs of internal systems, security management tools, and cloud services from the basis of organization threats analysis program. And next, it's process data. Here we do some collection and systemization of data that we get it in the previous stage. Then we need to analyze the data somehow. These steps involves searching for answers from the processed data to questions such as when and why, and also how the suspicious event occupied. And finally, we get report findings. Report should be tailored to the specific audience, so that is clear how to threat under consideration affect their areas of responsibility. Now, we would like to suggest you to take a look deeply into framework that can help us to perform threat analysis in context of 5G network. As you might know, the MITRE organization that actually developed TI framework of adversary behavior for enterprise, for industrial control and mobile systems already has developed a framework for 5G that called as FiGHT 2 years ago. This matrix is an ordered set of tactics and techniques that can be applied by the attacker to 5G mobile network. Part of these techniques was also taken from original attack matrix. This matrix contains well-known information about the methods used to hack the 5G network, as well as way how to against for this attack. So that means mitigations. But how can this framework be useful for us and everyone involved in telecom security world? Well, first of all, it's unified languages for security and network professionals. So also professionals can use FiGHT to translate technical details into strategic insights for leadership, focusing on how specific tactics and techniques could impact business objectives and assets. Let's say the second use cases during security assessment, professionals can use this FiGHT matrix to conduct a security gap analysis, identify what defense you have in place and where you're lacking. Also, it's helpful review your existing security controls and solutions to ensure that they cover, let's say, the tactics and techniques outlined in FiGHT, identify gaps and arrange improvements and controls. So the next point is about prioritizing controls. You can align your security controls with the FiGHT techniques that's the most relevant to your industry field. So also we can use MITRE FiGHT in threat detection and incident response, implementation, security information, and event management system solutions that aligned with the fight helps to facilitate, let's say, real-time monitoring of security events. This approach is also applicable for detection rules. You can utilize this framework to develop detection rules for your CM systems. MITRE FiGHT framework as a comprehensive knowledge base of adversary behavior also helps to train red and blue team. Like your blue team can use the fight to identify and defend against attack. And the last point is about vendor evaluation. As a company, you can use the framework to compare the capabilities of different security tools. It could be helpful in contractor assessment field when working with the third-party company, security firms. We can use FiGHT as a baseline to evaluate their expertise and capabilities. So now let's try to apply the described framework for analysis in 5G network. We will go through the main stages of the attack and consider what techniques should be applicable for that. The final goal of this example, I would say, it's performing denial of service attack for the victim subscriber. So the first of all, I should say that the preparatory part of the attack takes most of the attacker's time. The preparation period includes such tactics as reconnaissance, resource development, and initial access. So let's start with reconnaissance. For the beginning, the attacker conducts reconnaissance of the mobile network operator and of the victim subscriber. So to do that, we should discover IP addresses of 5G core elements. Basically, it's enough to find the address of network repository function, since these network functions store all the network functions profiles. Also, our intruder needs to prepare some tools to carry out a successful attack. There are many ways to do this, starting with generating your, let's say, own framework in any programming languages, like using open API specification, or you can use such tools like Burpsuit or Postman. After that, the adversary should think about the attack vector on the network. He can get into the network through the compromised roaming partners, for example. Roaming partners is also important attack vector. Even through the encrypted tunnel, the attacker have some possibility to send malicious traffic that can be affected your network. Or let's say even more, attacker may already be in IT infrastructure and then using various methods get into the signaling segment. So next step is intruder conduct exploration of the network in which he finds himself by getting all network functions profiles. So using these profiles that adversary received from NRF, he can find out the addresses for all developed services and many other information regarding network functions. So in the process of registrating of our subscriber on the network, the MF that's serving our subscriber put information in UDM network functions about the status of the subscriber. supporting features, writes down his own AMF ID and other info. And of course, the intruder can get this kind of registration profile from UDM. So on this slide, we can see examples of the execution of this HTTP GET request. In addition to other information, here we can see unique registration callback URI. This is typically used when UDM initiate user deregistration procedure. But if attacker also executes this HTTP request, registration for our subscriber to AMF registration, current session will be cancelled. After that, attacker received 200 code response. Subscriber, in this case, will be deregistrated, and then it will take some time for the phone to do new registration. This type of attack can be executed automatically with some of period, like one time per second. In this way, subscriber will lose 5G connection for the entire time of attack. I should say that attack constantly similar to cancel location request in 4G network. Well, now let's take a closer look at the recently published framework from GSMA that's called Mobile Threat Intelligence Framework, or MoTIF. Well, in general, this framework does not conceptually differ from the last one that we discussed earlier. So the team, based on the principles and structures embedded in MITRE attack, created a MoTIF framework using the accumulated in fraud and security group expertise driven by GSMA. The development is, let's say, very early stage for now, since there are no mitigation sections here, for example. Here we can see the example of this matrix. So reused MITRE attack techniques and sub-techniques are colored with light red. Also reused MITRE FiGHT techniques and sub-techniques are also colored with the light blue. As additional use cases and MoTIF version are in progress, additional techniques and sub-techniques will be identified later. And with asterisk indicates reused FiGHT techniques and sub-techniques, but with a different name. So actually, GSMA MoTIF consists of 50 tactics. One is unique, it's a fraud, pretty the same structure with that was used in FiGHT framework. All techniques divided into two types of techniques. The first one applicable for 2G, 3G, and 4G network, and the second for 5G standalone network. Also, some techniques are only available for GSMA members. So some of these techniques related to the topics such as initial access, global title scanning in S7 network, and diameter, realm scanning. And also we can see examples of well-known SRI 4SM attacks. Here we see just example of a scanning singling addresses technique that actually described how to sending singling messages to the network. The adversary can check if a mobile network nodes leak the unique ID or network-related information or it's also possible to bypass defense or not. You can check it using this, let's say, technique example. So this kind of scanning is applicable for previous generation network like 4G, 3G, and 2G. Also, here we see the section that like procedure examples and links to materials where this techniques is described in more details. Comparing these two similar tools for the threat intelligence, we can say that GSMA MoTIF is a younger framework, as a result of which MITRE FiGHT has more, let's say, described techniques at this moment. Also, we highlight that GSMA MoTIF driven by the GSM organization. At the same time, MITRE FiGHT driven by the community. And also FiGHT is a public framework, and GSMA MoTIF have some materials that are available only for GSMA members. So, Kirill, please, over to you.
Okay, thank you, Igor. So basically, Igor just covered the theoretical part, right, of the approach to the frameworks. And now let's actually look at how this can be used in a practical way. What can be the approaches, right? Let me share my screen quickly. Okay. Okay, and yeah, hopefully you can see it. So how do we identify the actual threats, right? So first of all, as most of you probably aware, the actual first pillar of NIST approach is identification. So how do we identify the actual threat? So identification is about developing an understanding of how the cybersecurity risks can be managed. And there are actually many ways to do this. So starting from tabletop exercises to paper risk analysis, right? But usually this is a complementary work of theoretical approach and practical approach. And the practical approach is specifically identification of the threats, to look for vulnerabilities in the network, to test if these can be exploited, right? And identify the actual list of the actual threats that are relevant specifically to your network or to your organizations. And for that reason, many companies establish specific special red team, right? That the main goal of which is to constantly test how the network reacts and to specific malicious messages, how it can be hacked, and at what step of the penetration testing, right, the defense team actually identifies the threats, right? And in our company, we have developed a special tool to automate this process of continuous verification of threats, and it's called Artificial Cybersecurity ACE, so you can call it ACE as a short. And it's basically a breach and attack simulation platform that allows continuously inspect the network and react on the changes that are happening within the network. So for example, if any configuration change is happening in the network, you might want to explore the security landscape, how it has actually changed because of the new device has been introduced or some security configuration has been changed. And of course, this can be done automatically and in a scheduled way, and it works for all the signaling protocols starting from SS7 till 5G. So now we go to the next one. Sorry, and the second one is about the protection, right? Protection function is essential one, of course, and it relates to the security configuration of the devices, of the network itself, and of course the specific devices usually called firewall, right? But the protection function of which is realized by the firewall, it's like it cannot work efficiently in isolation. So first of all, the we do understand, and unfortunately, we see it in the real networks, that sometimes the protection devices can be bypassed, and it happens not always because the firewall is not configured properly. It might be that the network itself and the routing that is in the place, or the routing changes that has been introduced within the network are not, let's say, quiet, actually propagating the security function. And it's quite important to be able to control this kind of execution, right? The firewall execution, and to be able to, let's say, be sure that the firewall actually works as it is configured, right? And no traffic actually passes not through the firewall. And in order to do this, the third, let's say, pillar, right, of our approach, which is detection, is IDS is introduced, right? So it's about taking the traffic, the interconnect traffic, before it actually reaches to the firewall, and analyze it. So the IDS doesn't only, let's say, check the work of the firewall, like if firewall skipped some blocking, or if the traffic actually missed the firewall, and that's why the attack actually happened. But it also helps to identify the threats that have some, let's say, 0 days, for example, or to help to identify the threat that is too early to implement on the firewall rule, but requires some constant monitoring and understanding the exact rule that can be introduced in order to withstand the future potential threat. And all in all, right, we understand that the threat intelligence, the being aware of the information of the existing attacks and tactics, is quite important. And basically, it is the key, right? So as the chess players, they study different techniques and attack tactics as well, right? So that they can respond without hesitation, because they know the best way to defend against the attacking step, right? The same way, basically, security professionals may use these tactical adversaries, news, whatever sources of information for the threat defense, right? So we also take this threat-related information that we have from telco-specific research, security monitoring, security assessments, industry collaboration, whatever. And we actually, let's say, process it and put it in a specific form into the knowledge base. And the knowledge base, right, it's not only put like in some specific model, right? The knowledge base is actually being distributed between the models that we just described previously, right? So it's about the monitoring, the knowledge base of the monitoring system. It's about the firewall, so that we have the proper instruments and proper tools to actually set specific firewall rules to protect the network. And of course, this is the knowledge base of a breach and attack simulation platform that can perform the attack just to simulate it for the personnel to be aware, like, is our network vulnerable to this or not? So, and let's specifically look at the example, how it may work. So here, let's look at the picture. We have the network, right? And different type of devices, IPX connection, switching, routing devices, specific network function, applications, etc. So this is where we can actually deploy threat monitoring, right? Preferably, of course, this is being deployed on the perimeter, and if possible, within the network as well. So should the bad guys initiate their malicious activity, we have a chance to detect it, right? And then, of course, these monitoring tools, they do communicate about this kind of activity to the SIM or SOR, so security event management platform, or security automation response system, which then can propagate it further, right, to the system in place, like the firewall, like specific, for example, switch that can block the IP address directly, the attacker itself, or can isolate the activity coming from specific address, specific networks, etc. So, and moreover, if, for example, there is an integration of monitoring system with the firewalls, they can notify the firewall about the detected threats so that the firewall can prevent any further activity happening before that's happening further, right? And of course, this approach significantly enhances the efficiency of network defense, right? And enables it together withstand the attacks and protect against threats that, for example, were not visible before, right? And during the calm period, right, when no attack happens and network is not under attack, like it's actually an ideal time for training, exercises, etc. So, and in order to do this, it's pretty much the same, right? But in order to simulate the attack, the breaching attack simulator will be used. So you can see on the left side and on the right side, there is a breaching attack simulation model, right? That actually generates the attack against like the same simulation of the attacker activity. Of course, to some limited extent, not to exploit the network to a disaster, right? But just aiming a test subscriber, for example, and checking if the network is vulnerable to this vulnerability or not. So the goal is the same, to test and identify what vulnerabilities are exploitable, right? And it helps to understand better security posture and to improve the detection and mitigation policies within the organizations. So here we talked about the some kind of internal approach, right? But usually, sometimes it is very beneficial for the companies to invite an external team for conducting cyber drills, so that it's not just the red team and blue team train inside the company with the help of some automated tool, but the external company is being invited, right? Which actually unites the efforts within the team of operator. It checks the effectiveness of processes, and in this situation, the teams, the blue team, the red team, security department, network department, they will have to work in a cooperation, in a very tight connection with each other, because it's their main goal to detect the threat as soon as possible, to mitigate the threat as soon as possible, and so on. So, and this actually helps pretty much to understand what are the weak points in the communication, what are the weak points in security configuration, in the technologies used for security defense, etc. And it actually has proven itself as a really powerful tool, because we had last year several positive experience with the cyber drill, where we helped the team to improve their communication and also highlighted the weak points, and together with them fixed them and rechecked that the system is actually protected from these kind of threats that were found vulnerable. So this is it. This is my part of the presentation. I think we're open to questions now, please.
Okay. Thank you, Igor. Thank you, Kirill. Thank you, everyone, for listening to our pitch. And Kirill, Igor, while you were talking about the presentation and threat intelligence, there were several questions that we have received at the back end, and I will try and pick up a few and address those so that we do justice to them while the time is still on our side. So question for you, Igor, and the question is, in what form can threat intelligence come? Who distributes threat intelligence related to MITRE FiGHT today?
So for today, I would say MITRE compression is the main driver of this framework, and yeah, it's also driven by the community. Like, for example, Security Gen is also have some contribution in this framework.
Okay, thank you. There's one more question for you, Igor, for your part of the presentation. And the question is, What is the purpose of having two frameworks? Is it intentionally divided, or is it more of a sudden overlap? Like the MITRE FiGHT and GSMA MoTIF. I believe this question is pertaining to that.
Yes, thanks for this kind of question. For now, it looks like more like a coincidence since the developing stage of these two framework was started almost at the same time. But I would say the persistence of these two frameworks and persistence of the competition among them for the audience, for the telecom community, is certainly good benefits for entire, let's say, telecom community.
Yeah, thanks. There's one more for you, Igor, before I start tackling the questions which pertain to Kirill's section of the presentation. So this question is: the GSMA framework looks like a copy of MITRE ATT&CK. What is the purpose once again? Do I get it right that it is created to cover legacy technologies like 2G, 3G, which are not mentioned in the MITRE's framework? Do you want to repeat, Igor? Okay.
No, I get the main idea. So actually, it's not exactly the same copy of the MITRE framework. So GSMA, based on the knowledge and based on the CVD program, add some new features. And I would say, let's considering GSMA MoTIF framework like additional, let's say, part of the big MITRE framework. And also we can analyze only the public part of this framework. So, I mean, GSMA MoTIF. So, let's say they also have some, let's say, internal networks that we cannot be shared, let's say, in the public webinar.
Okay.
And yes, for now, the most common, let's say, part of the described techniques, mostly about the previous generation network like 2G and 4G.
Okay, wonderful. All right. I guess, Kirill, now we have a couple of questions that have come in for your section. So the first one is breach and attack simulation similar to vulnerability testing tools?
Mm-hmm. Thank you for the question. So yes, it is in some extent. It is similar to vulnerability assessment tools, right? But usually, when we talk about these kind of tools, they usually rely on the personnel already experienced and has quite some knowledge, right? And can properly actually analyze the result, the response from the network. While the breach and attack simulation tool, they try to automate as much as possible. So they treat the responses, the network reaction, etc., and the outcomes, the possible outcomes and threats vulnerable in a simplified format, so that even the user that doesn't have, let's say, for example, telco specific knowledge in security can actually treat these results quite, let's say, quite reasonable, right? And being able to communicate with the network guys, with the security guys on the same language. So that it very simplifies the process of vulnerability testing.
Yeah. All right. There is just one more, Kirill, and it is: where do you get the information relative to these threats? Is it sufficient, and how to guarantee that it's continuously populated and up to date?
Yeah, so as I previously mentioned, right, where threat intelligence is coming from. Of course, it's coming from our security assessment that the guys continuously perform throughout the year, right? It also comes from the lab research. Of course, the sources that publish this kind of information, again, some kind of MITRE, right, GSMA, etc. So all this, let's say, not knowledge base mass is actually coming into our products, and of course the massive amount we get also from our experience, right? And the one things that we identify on the customer installations, on the customer assessments, etc. So yeah, and it's continuously populated. It's it cannot be a process that, okay, now we know everything, you just buy this box and never update it. No, it doesn't work this way.
Okay. One more, Kirill, if you can help us with an answer. And the question is, please tell me more about cyber drill. How is it organized and run? Is it conducted like testing attacks in a controlled environment, or is it a silent exercise for defenders?
Yeah, it's more like an exercise for defenders. Of course, let's say the teams are aware that the cyber drill is going to happen. It depends on how, let's say, we negotiated with the company, but usually they are, but they don't know specifically what's going to happen. And so basically, yes, this can be, let's say, organized with specific department, right? While the other department will not be aware. And it depends on the how the company is actually structured. But usually the teams are let's say involved, and they are aware. And also it comes with let's say, it can come with two paths, right? One can be just active testing, and then just analyzing the response times, the results, helping to improve the process. Or it can be like an analysis of some situation that already happened in the network, and our experts get the logs, the pickup data, for example, just to analyze what happened and help the teams to identify what actually happened within the network and how they should have reacted to this kind of incident. So something like that.
Okay. There are a few more for Igor while we were talking to Kirill. So Igor, yeah, we have two more questions that have come for your section of the MITRE FiGHT and GSMA MoTIF. And the questions are, Igor, you can hear me?
Yes, sure.
Okay. Is MITRE FiGHT intended to replace attack, or is it more of a deep dive when the attack targets 5G infrastructure? How should a security team that deployed attack utilize FiGHT?
So actually, MITRE FiGHT can be used once we are starting to talk about the 5G in general. I mean, the MITRE FiGHT describes not only, let's say, radio part and the signaling part of the network. We can also find some, let's say, big part of techniques that described, let's say, common IT threats. Let's say for OSS, BSS systems, and many other.
Okay, Igor, there's one more question that I see in the panel, and it is, I see most of the threats raised come from external attacks. For example, IPX via SS7 diameter. How about internal threats from the internal RAN part?
Yes, thank you for this question. Let's say we are talking about if we are talking about the MITRE FiGHT, I would say that they also have some description of such kind of attack for the RAN part, and let's say many other, like for management system, etc. So yeah, this kind of information is also included in and described in a MITRE FiGHT framework.
Okay. Few more are coming while we are talking, Igor. So another question that have just popped up is, I see most of the threats raised, similar question, how should we handle threats possibly coming from multiple vectors such as RAN, OSS, BSS, and APIs? Does this framework help identify and manage such threats?
So I guess it's mostly about Kirill presentation side. So
Yes, so
Could you
yeah,
help me?
let me comment. So regarding the threats coming from multiple vectors, of course, it's a combination of the tools, right? So that's they provide the API security, so it can be like the regular IP firewall, for example. For RAN, for example, we have the service that is called Radio Access Network Security Assessments, where our experts can actually, let's say, test the network if it can be, let's say, exploited from the RAN side. And the same refers to OSS and BSS. So yes, it's a consolidated approach of combination of different tools. Right, so you cannot name a silver bullet that actually protects from all the interfaces, but of course, they all do require specific and precise attention.
Yeah, all right. This sounds good. I guess we are nearing to the close, and we have addressed a lot of questions. So Igor, Kirill, thank you once again. And audience, thank you so much for listening to our pitch, contributing via your interesting, intelligent questions to make this topic all the more interesting and engaging. And once again, we are going to be sharing the recording of this presentation and webinar with you very soon, maybe by tomorrow morning latest. And we'll also have a detailed note wherein you can reach out to an expert from our side if you may want to know more about this topic or anything to do with threat intelligence in telecoms. But this was very good, and thank you once again, and hope to see you soon again. Take care, everyone.